Alright, hello everyone, so welcome back. Now let's start doing tricky problems in integration by substitution. Okay, so this problem, what is inside function? What is our substitute? Well, the inside function is a little bit obvious, right? So we can take it like x square plus 21 because it is inside square root. So it looks like really an inside function, right? Okay, now what is its derivative? The derivative of x square plus 21 is 2x. Now do we have 2x somewhere else in the integral? Well, we have x cube. Inside the x cube you have x because x cube is x times x times x. So yeah, sort of a, not 2 but sort of x is inside the integral, somewhere else in the integral. So maybe yes, we can use integration by substitution. So let's give it a try. Derivative of u is 2x. Okay, so then dx is du over 2x. Alright, now let's substitute. So we have x cube square root of u dx is du over 2x. Now we can see 1x cancel out, but we are left with a x square, right? Because we were not able to cancel out x cube, just a x, right? We only cancel out just a x. Now this is what we left it. Now this problem is similar to the previous problem. Well, previous problem means the last problem that we did in the previous video. So above this video in the link that appear, you can go to that video. Now in the last video, last example, as I explained, in the last example, we were not capable of, or we couldn't cancel out any term. Because of that, we left with the extra term like x square. In that example, I think we left with x. But here, even after cancelling x term, we still left with x square. That means this integral is not written totally in terms of u. We have mixed variables x and u. Now what do we do here? Well, the same strategy, we can use the same strategy. That is a tongue twister, right? So as the previous video, which is, okay, I want to write this x square in terms of u, right? But how can I do that? Well, I can use the help of the substitute. Because what is x square based on the substitute? X square is u minus 21, right? So let's write it down. So x square is u minus 21 times square root u du. Now we have an integral written in terms of just u, right? So we are on the right path. But it looks a little bit complicated, but we can still integrate this new integral with respect to u using basic integration rules. How can we do that? Well, that square root u, I can write it as u to the half. Well, that's a start. Now what else we can do? Here we can use an algebraic trick where I can FOIL everything, right? We can FOIL u minus 21 times u to the half, or you can bring that u to the half into the parentheses. So it will be u times u to the half minus 21 u to the half. Now here we can simplify. It's u to the power 1 times u to the half. Now using power rules, we can add 1 and half, which is 1 plus half is u to the 3 over 2. So this is really u to the 3 over 2 minus 21 u to the half. Now at least, now can we integrate this? Yes, we can. We can integrate these two terms separately, right? Because it's separated by subtraction. And yes, so integral of u to the 3 over 2, it's u to the 3 over 2 plus 1 over 3 over 2 plus 1 minus 21. This is u to the half plus 1 over half plus 1. Plus arbitrary constant c. Okay, so 3 over 2 plus 1, which is u to the, I'm gonna do it quickly, 5 over 2, here 5 over 2, and minus 21, here 3 over 2, divided by 3 over 2 plus c. Now what we can do is, well, we can write this 5 over 2 as reciprocal multiplication. So it's 2 u to the 5 over 2 over 5. Minus, take the reciprocal multiplication of 3 over 2. So it's 2 times 21 over 3 u to the 3 over 2 plus c. 3, 21 cancel out and give us 7. So 2 u to the 5 over 2 over 5 minus here 14u 3 over 2 plus c. Okay, last step is to replace u back. What is u really? U is x square plus 21. Alright, so 2 x square plus 21, 5 over 2 over 5 minus 14, x square plus 21, 3 over 2, that's it, plus c. So that's the solution for the integral that we started with. Okay, so now this is a one trick. Okay, this problem combined with the last problem that I did in the last video. Now what is the trick? Whenever you have these excess terms, the way we get rid of them is use the substitute itself. Use u. Use what is u equal to and rearrange that. Here we know that x square is u minus 21, then we can use that fact. Probably when you do that, you might need to simplify your integral using algebraic rules, right? Like foiling. In the last example we saw that we had to divide each term in the numerator by denominator, so something like that. Alright, now I'm gonna show you a new integral, new problem that comes with a new strategy. Okay, x cubed over 1 plus x to the 8. Now this is really tricky. Okay, now don't worry the fact that you don't see the idea or the way to solve this problem right away. It always comes with experience base. Alright, so try to Google and try to find lots of examples, more examples for integration by substitution. Solve as much as possible, then it will become your second nature. That's my advice. Now here, okay, now to solve this problem, what is the inside function? Inside function, you might think, well, u is x to the 8 plus 1. Okay, all right, I agree with you. Okay, let's try to move on. Its derivative is 7x to the 8x to the 7. What I'm saying? 8x to the 7. But here's what happens. Okay, so let's try to fold into trap. So du over dx is 8x to 7. Now if you substitute, this will be 1 over u x cube. Dx will be, well, what, du over 8x to 7. So x cube, and here we will, if you cancel out x cube, it's going to be x to the 4. So what we are left with is du over u x to the 4. So we still left with an extra term, x to the 4. How can we get rid of x to the 4? Now I said to you that we can use the substitute, but here we have it in terms of x to the 8, not x to the 4. Well, you can take u minus 1 square root. That will be x to the 4, but still looks complicated, right? Okay, so that didn't work. Try to do it by yourself. So the integral will be like this, u square root u minus 1. Okay, I did that fast, but because that's the wrong way, it still looks complicated, because you cannot integrate using basic integration rules. Think about it. Those are good things to think. Okay, now that trick doesn't work. Now what can we do then? Well, definitely we have to change our u, because that's the root of the problem. What can I choose for u? Here's the smart thing we can do. Well, your substitute, let's decide our u is coming somewhere from here. Now when you choose that u, what I really want to happen is to cancel out that x cube, right? Then we have no problems. Think about it. If I can have a replacement of u here, and for that inside function, if I can cancel out x cube, that will be great, right? That is my thinking process, because that's what usually happens in easy integration by substitution problems. Now to cancel out x cube, it should be derivative of u. So what should be u? X to the 4, right? Think about it. Derivative of x to the 4 is actually 4x cube. Forget about 4, it's x cube. Okay, so x to the 4, is it an inside function? Well, x to the power 4 is inside, even inside that function, right? Inside x to the 8. Try to see what I'm trying to do. So this is x to the 4. That's what I'm trying to choose. So du over dx is 4x cube. Now let's see, dx is du over 4x cube. So let's substitute these two back to the integral. So x cube over 1 plus, now x to the 4 is u. Then what is x to the 8? X to the 8 is x to the 4 square, right? So this is u square, right? X to the 4 square is u square. Dx is du over 4x cube. See, x cube cancel out. Now what we get is 1 over 4 1 plus u square. Alright, so this is what we get to integrate. Now we can take that 1 over 4 out from the integral. So we have to integrate 1 over 1 plus u square. Now how can we integrate this one? Well, this is tangent inverse u, right? 1 over 4 tangent inverse u. Now in case if you have forgotten that, watch my basic integration review series. The link appears in the top of this video, plus c. Okay, that's a basic integral. Now this is 1 over 4. What is u? X to the 4, I believe, and that's it. This is how we solve the problem. Okay, now what was the magic here? The magic here was the thinking process here. X to the 8 didn't work, so we had to choose x to the 4 so that we can cancel out x cube. So your choice for your substitute, choice for your u is an inside function. Still x to the 4 is an inside function because it is inside x to the 8. But it was a smarter choice that reduces our workload. Okay, all right, so that's a really special trick. All right, so now I'm gonna finish this video off with another easy problem. Now I'm not gonna do the 6th problem in exercise 6 because I shouldn't have put it there. I will discuss that in trigonometric integration, but I will do the 7th problem. Okay, now one last thing I want to discuss here. This is not a hard problem at all, but it can trick you. It can guide you to do wrong things. Okay, what is u here? What is the choice of u here? Well, square root t is inside exponential function, so let's choose u to be square root of t. I like to write it as t to the half because it's easy to deal with. Now derivative of u with respect to t is half t. Half minus 1 is negative half, right, when you take the derivative. Now here's a question, here's a thing that comes to your mind. When you decide that your inside function is square root t, you right away neglect it. The reason is you might think, well, its derivative is not somewhere else. You might think, well, it's t to the negative half, the derivative. Of course it is, and you cannot see t to the negative half everywhere, anywhere else, not everywhere, anywhere else in the integral. So this is not integration by substitution, or we need to use a special trick, but we don't need. T to the negative half is, we can take that down to the denominator, so it becomes t to the half on the bottom. So it's 1 over 2 square root t, right? And we have 1 over square root t in the integral. We we didn't see it explicitly right away. Understand the difference. So don't jump into conclusions right away. Okay. Oh, I forgot a step. So what is dt? So du over dt is 1 over 2 square root t. So dt seems to be like 2 square root t du. Okay, let's substitute. This is e to the u square root t. I want to see that cancellation by myself. 2 square root t du. This cancel out. Perfect. Now we have the easiest integral to integrate. So this is 2e to the u. We can take 2 out. Integral of e to the u is e to the u plus c. So 2, what was u? Square root t. And this is the answer. Alright, so that was easy. Alright, so this is the conclusion of integration by substitution video series.